Assalamualaikum and hi everyone. My name is Asha binti Muhammad Taufik and I'm from class L4B. Today, I would like to present my assignment poster with a title, A New Design of Electromyography or EMG Sensor for Human Movement Detection. Before we begin, let me ask one simple question. How can a machine can detect our muscles movement just from electrical signals inside our body? The answer is through a technology called electromyography, or we call it in a short form as EMG. EMG is a biomedical technique used to measure electrical signals produced by muscles during contraction and relaxation. This technology is very important in biomedical engineering because it can be applied in rehabilitation system, prosthetic control, exoskeleton system, and also human-machine interaction. However, EMG signals have one major problem. They are highly sensitive to noise and interference such as motion artifacts and muscle crosstalk. Because of this problem, the signal can become unstable and difficult to analyze. Therefore, these studies propose a low-cost multi-channel EMG sensor using filtering circuits and a driven right leg DRL circuits to improve signal quality and movement detection performance. Now, I will begin explaining about the operation principle of the system. At first, AG or AGCL electrodes are placed on bicep brachii muscle to detect electrical activity produced by muscle movement. Since EMG signals are naturally very weak, the signal first enter the AD620 instrumentation amplifier. This amplifier helps straighten the EMG signal while reducing the common mode noise. After that, the signal passes through a high-pass filter with a cut-off frequency of 20 Hz. This filter removes the low-frequency motion artifacts caused by body movement. Then, the signal continues through a low-pass filter with a cut-off frequency of 440 Hz to remove high-frequency noise and smooth the signal waveform. One of the most important parts of this project is the DRL circuit. These circuits reduce power line interference by feeding an inverted common mode voltage back into the body. As the result, the EMG signals becomes cleaner, smoother, and more stable. Next, the filter signal amplified again before entering the ADC, which is analog to digital converter. And lastly, the EMG signal is analyzed and displayed on a computer for movement detection. Let's move on to the block diagram section. The block diagram illustrates the EMG signal processing flow. The process starts from electrodes, followed by differential amplifiers, high-pass filter, low-pass filter, main amplifier, ADC conversion, and finally the computer for signal processing and analysis. The DRL circuit also play an important role for reducing unwanted interference for better quality signal. Move forward to the next section. I will explaining about the results and the findings. The performance of the EMG system was evaluated using signal to noise ratio or SNR analysis. Two reference methods were compared, which are the DRL reference and the conventional ground reference. Based on the result shown in the poster, the DRL reference achieved an SNR value of 23.09 decibels, while the ground reference achieved only around 20.01 decibels. This proved that the DRL circuit successfully improved the signal quality and reduced noise interference. Besides that, the EMG waveform using the DRL reference appears smoother and cleaner compared to the ground reference waveform. The poster also shows the PCB design and the prototype of the developed EMG acquisition board. The system used a low-cost design with a total component cost of approximately $10, which is significantly cheaper compared to commercial EMG devices. In addition, The experiment setup shown in the poster demonstrate the electrode placement on the bicep brachii muscle during upper limb movement testing. Overall, the proposed EMG sensor successfully detected muscle contraction and relaxation with better signal stability and lower noise. All in all, for the conclusion, this study successfully developed a low-cost multi-channel EMG sensor with improved signal qualities using filtering circuits and the DRL reference system. The purpose of EMG achieved better noise reduction and higher signal-to-noise ratio compared to the conventional ground reference method. Overall, this system is suitable for applications such as rehabilitation technology, prosthetic control, exoskeleton systems, and human-machine interaction. This project also proves that low-cost EMG system can still achieve good performance when combined with proper signal processing techniques. That's all from me.